The 30th of September, the last day in September. Okay? Wake me up tomorrow, because that'll be when September ends. Okay. Emily, you got that one?
Yeah.
I noticed you got that early, and you were just like, oh my gosh, this is terrible. Okay. SMBA students will be able to graph linear equations, section 4.3. So when we solved equations with one variable, you guys remember solving a bunch of equations with one variable? We did that even in our warm-up. Okay, we solved equations with just one variable. We got how many solutions? 1. Almost every single time we got one solution. Rarely we got infinitely many, and then rarely we got no solution. But almost always we got one solution. An example, 3x plus 1 equals 10. How would I solve this equation? 3x plus 1 equals 10. Subtract 1 on both sides. 1 minus 1 is 0. 3x equals 9. Now what, Tucker? Divide by 3. In total, what's x equal? Nine divided by 3. Or how many times does 3 go into 9? Yep, 3. Okay, so we got one solution. In this case, to this equation, the only thing that makes the equation true is 3. Nothing else will make this equation true. When we solve two variable equations, we'll have an x and a y. The solutions are what we call sets of ordered pairs. We kind of talked about this a little bit the other day. They're sets of ordered pairs, as in our x comma y. We will be looking at what we call linear equations, which are equations whose graph forms a straight line. So it's an equation, and if you graph the equation, which we'll learn how to do, you'll make a straight line. The solutions to an equation are all the coordinates on the graphed line. So any point that is on the line is a solution. So as long as you have the correct x and y, it'll be a solution. So there's a ton of solutions now. We can use a table to find some of the solutions and then draw a line. So we can use a table to help us find solutions to this, to our equation, and then draw a line. We're going to practice. So we're going to graph the solutions to each linear equation by making a table and then graphing the coordinates. You guys remember making a table a couple of classes ago? Okay, we made an XY table. And we said, okay, we have our x on the left, the y's on the right. So now what we're going to do is we're going to plug in an x. We're going to plug in an x, just like putting money into the vending machine. And what are we going to get out if we plug in an x? Go ahead and say it louder, Maddie. We're going to get a y out. Very good. We're going to get a y. We're going to plug in an x, get a y out. You're plugging in $2.25 in the vending machine, you're pushing the button, and you're getting, let's say, Twix out. I like Twix. Okay? So we have this equation, y equals 3x plus 1. Now we can choose to plug in absolutely anything we want. We can choose to plug in absolutely anything we want. Here's what I'm going to recommend. Okay? I'm going to recommend we're going to plug in -2, -1, 0, 1, and 2. Go ahead and write that down, and I'll tell you why I recommend plugging in these.
You put in randoms?
You can put in any numbers, but I'm going to recommend doing these 5 almost every time. And I'll explain why. So the reason why I like plugging in these 5, because it gives us a pretty good balance of what we're doing here. All right, we're plugging in pretty small numbers. We're not plugging in big numbers like 13 or like 500. Okay? So like -2, -1, 0, 1, and 2 are decently small numbers, right? We're not plugging in fractions, okay, to make our life harder. Okay? We're plugging in a 0. We like working with 0. 0 is pretty easy to multiply and add, right?
Yeah.
Okay? Is 1 pretty easy to multiply and add with? Okay, -1 is 2, because then it's the same thing as what you do with 1, but you just have the negative sign, right? Okay? And then -2 and 2 are also not too bad. But then we also still get kind of we get to see what's happening when it's negative and positive. So we aren't just picking 5 positive numbers, because we want to see what's going on when the graph is negative and positive for x values. Okay? So we're going to choose these 5 here. And Reagan's already going on this one.
Me too.
And so, and you are too? Okay. So what are you doing if you're already going?
You plug, okay, so you go y equals 3 times -2 plus 1.
Very good.
And then you do it for all of them.
And you do it for all of them. Okay, whatever we get from our first one, y equals 3 times -2 plus 1, that'll be y equals -6 plus 1, and y equals -5. So we're going to put -5 for our y. It's going to be -5. And that's a point. -2, -5 is a point. So I'm going to go over to my graph, and I'm going to graph -2, -5. That's an xy point. And then you'll do the same thing with -1. Same thing with 0. Same thing with 1. Same thing with 2. I want you guys to go ahead and try the rest of these and graph them.
Big bet.
Emily, I'll awkwardly ask you while you're finishing your drink, what's the y value of -1? When x is -1, y is? -2. And we'll graph that. -1 comma -2. Okay. Tucker, when x was 0, y was 1. Okay. When x is 1, Hannah, y was 4. Okay. And then Lainey, when x was 2, y was 7. Now we should be able to connect these and make a straight line, and I do want you to connect them and make a straight line, or what should appear as a straight line. And it should hit all those points. A tool you can use to check yourself is saying, hey, does a straight line connect all those points? Yes, okay, that's a good chance you got it correct. If it doesn't, you know you did something wrong. Okay, questions on that? Now, we are saying that not only are these 5 points solutions, we're saying that every single spot on this line, so even, look at the board, even here, that's the solution. Here's the solution, here's the solution. Everywhere I'm tapping on this line is a solution. So we're really going to have an infinite amount of solutions. But notice, the x and the y have to be a specific pair in order for it to work, right? So just because we have infinitely many solutions here doesn't mean that everything's a solution on this one. Just because we have an infinite amount doesn't mean everything's a solution. Does that make sense? Okay. Continue on. I want you guys to try number 2. When you have it or have questions, raise your hand. And we're going to have our XY table. And we're going to try plugging in these same 5 again. Once again, I pick these 5 every time because it gives us a good number of points to do. 5 is preferred. And it gives us a good array of negatives and positives, but makes our numbers pretty manageable to plug in typically. Okay? So as we plug these in, y equals -x plus 5. So that's negative of -2, because -2 is our x. So you have to be very careful. That's why I'm a big proponent or supporter of using parentheses. What happens when you have those 2 negative signs in a row? It's a positive. You can also think that as a -1 times -2, and negative times negative is a positive. So either way, it's +2 plus 5. What's 2 plus 5? 7. Next one, y equals negative of -1 plus 5. Well, negative of -1 is a positive 1 plus 5. So 1 plus 5? 6. Mason, what's the next y? When x is 0, y is?
Wait. On 0?
Yep.
5.
5. Tobin, when x is 1, y is? Do you have it yet?
Yeah, I got 6.
Okay, ooh, I'm going to disagree. I think that's for the case for -1.
No. I got, yeah. I did it wrong.
Okay, let's try it up here, okay, Tobin?
Yep.
Y equals negative, plug in the 1,
Yep.
plus 5. What's -1 plus 5, Tobin?
Oh, that would be negative, yeah.
So are they the same sign or different signs?
Different signs.
Different signs, what do we do?
Add.
Subtract. What's 5 minus 1? Okay, and which sign is bigger? Which number is bigger, 5 or negative 1?
5.
So is it positive or negative?
Positive.
Positive, so it's positive 4. And when x is 2, y is what, Emily? 3, very good. So we can plot these. Negative 2, comma 7, negative 1, comma 6, 0, comma 5, 1, comma 4, and 2, comma 3. And notice, hey, these do make a straight line again. Connect our dots and make a straight line. Yes, good luck. Questions on this one? Alrighty. Give me a thumbs up if you're feeling good on these. Thumbs down if you're not feeling good. Nowhere in between. Thumbs up if you're feeling good. Thumbs down if you're not. Nowhere in between. Okay. Next one we're going to do is number... We'll do number 3. Go ahead and try this one when you have it or have questions. Alrighty. Y equals 4 minus 3x. We have our x comma y. I'm going to try my same 5. Negative 1, negative 2, negative 1, 0, 1, and 2. Now here, when I plug in negative 2, a lot of times when we ask ourselves, we try and do this in our head. And we say, okay, what would be this? And we kind of mix ourselves up. So if writing it out can be really helpful. Y equals 4 minus 3 times negative 2. Now we can think of this in one of two ways. We can say, hey, that's really like a negative 3 times negative 2. What's negative 3 times negative 2?
Positive 6.
Positive 6. We have 4 plus 6 and get 10. The other way to think of that, on the same exact thing, I'll do it on the next problem. So I have negative 10 here, or positive 10 here. If I do on another problem, I do y equals 4 minus 3 times negative 1. And then I can say, okay, I can leave the 4 minus there. And what's 3 times negative 1? Oh, it's negative 3. But now, I have 2 negative signs in a row. So what do I do? Negative positive. Do we end up accomplishing the same thing anyway? Yeah, we add them whether we think of it as a negative 3 times negative 2 or negative 3 times negative 1, or we think it as 2 negatives in a row. And y equals 7. What about when x is 0? What was y, Tobin?
It was 7.
Try again. When x was 0, y was?
4.
4, there you go. Maddie, when x is 1, y is? 1. When x is 2, y is what, Reagan?
Negative 2.
Negative 2. I'm going to graph this. Negative 2, comma 10. It does go off the graph. Negative 1, comma 7, 0, comma 4, 1, comma 1, and 2, comma negative 2. Connect them. It does make a straight line, which is a good sign. Questions on that one? Thumbs up if you're feeling good. Thumbs down if you don't. No in between. I want everyone to vote. Thumbs up if you're feeling good. Thumbs down if you don't. No in between. I want everyone to vote. Thank you. This next one. Y equals 3/4 x plus 1. Oh no, fractions!
Why do you do that to us?
Okay? Because that's how you guys like actually end up reacting. You're like, oh my gosh, you can't do this. You get shut down.
I don't do that.
Fractions in our homework?
To make you guys practice with them.
Fractions are fun.
Yeah, to make you guys practice with them and get better. You guys are better with fractions than you guys were at the beginning of the year.
Do we use this kind of stuff though?
Yeah, X and all that.
Take your diploma so that you can move on into the real world first.
Okay, so that is part of it. Okay, to kind of quote unquote go through the hoops. Okay, another thing though is, so you might not use this necessarily at the store. Okay, but depending on what your career might be, you might use it. Okay, so let's say you're going into something with stats or accounting. Okay, you might need it. Let's say you're going to be a math teacher. You need it. Okay, let's say you're going to do anything where you're designing a formula. Okay, maybe you're trying to project sales for a company. Maybe you're trying to start your own company.
I'm trying to look at
You could
dead
use
bodies.
this.
I'm not trying to do math.
You're trying to do what?
Look at dead bodies.
Doesn't
I'm not trying
science
to do
teach
math.
that too?
Okay, depending on if you own if you're trying to run your own company or not eventually, you would need some of this.
What do you mean?
Like legit. Okay? A lot of business stuff will end up incorporating this formula. This equation. You'll talk. Good questions though.
Does sports require that?
Well, if you want to maybe figure out how much you should get paid, or how much you should pay an agent, or that kind of stuff,
Yeah.
or negotiating a contract.
We would never use X.
Okay?
Y.
Okay? So you might call X years and Y dollars.
Yeah.
So you're using the idea behind
Just
it.
stop arguing.
Well, no, I mean, that's okay. You're using the idea behind it. So even if you don't call it x, x is just representing something anyway. It's a variable. X could be anything. So it could be years. Well, it could be dollars. We're calling it generically right now so that it can be applied to so many things. Yeah. No, it's a really good question. Now, in this one with fractions, let's say I did try to plug these in normally, okay? Don't write this down. Let's say I did try plugging in -2, -1, 0, 1, and 2. Let's say I did that. And I plug it in, y equals 3 over 4 times -2 plus 1. Well, here I'm going to have to cross reduce. I'm going to have 4 and -2 going to go to 2 and -1. I'm going to get y equals -3 over 2 plus 1. Now I got to get common denominators. I got to go through all of this. -3 over 2 plus 2 over 2. And I get y equals -1/2. I'm like, how do I even graph a fraction? My goodness. Okay, all this stuff. Okay? But did I say earlier that we have to do these 5 and there's no choice with it at all? No, I said we can pick whatever numbers we want. And typically, most of the time,
No, there's no order.
Oh,
okay?
really hoping you just
Rude. Typically, most of the time, these 5 are the easiest. But here, when we have a fraction with the x, it's not going to be the easiest. Okay? What number could I plug in to make multiplying with this fraction a lot less bad?
0.
Okay, plug in 0. Okay, so maybe we want to keep 0. Okay, maybe we want to keep 0. Reagan said 1, so maybe let's try 1. Okay, let's see what happens there. Y equals 3 over 4 times 1 plus 1. So y equals 3 over 4 plus 1. Is that still going to be very fun, though? No, we're still going to end in fraction, so we probably don't want 1.
0.
Okay, we like 0. We know we like 0. Okay, we know we like 0.
Can we just do 0?
Okay, ooh, we need more than 1 point, though, because here's the thing. If we just do 0, which we can try for a second, y equals 3/4 times 0 plus 1. Well, what's 3/4 times 0?
0.
So y equals 1. Okay, I plot my 0.1. Do I know where my line is?
No.
No, we need more than 1 point for a line.
It could go anywhere, actually.
Okay? You have a minimum of 2, but we like to do more than 2 so we can actually double check our work. Okay? But you need a minimum of 2, okay? But we always do more just in case, okay? Now, what if I plug in 3? Would plugging in 3 help here?
No.
Okay, what about if I plugged in 4?
How about 1? No. We already did 1.
You guys don't think plugging in 4 would help? Let's try it, though.
Well, you sure think so.
Just humor me.
You sure think so.
What's going to happen here?
Over 4.
4 over 1. What's going to happen?
Cross reduce.
Those are going to cross reduce. What are they both going to go to?
1.
So I'm left with 3 times 1, which is 3, plus 1. Did I end up with a fraction?
No.
Oh. So is 4 so bad?
No.
No, I guess not.
I guess not.
Maybe no.
Nope.
Can we just do -4 for the other one?
Okay, let's try -4. Okay, 4 works so well. Let's try a negative version.
So smart.
Y equals 3 over 4.
What, you're putting them in like special orders, so.
Well, least to greatest. So we decided to skip over 1, 2, and 3. And then so I'm assuming we're skipping over -1, 2, and 3.
Yeah.
Okay, what's going to happen with that 4 and the -4? Cross reduce to 1, and what kind of 1? Negative. So we have y equals -3 plus 1. What's -3 plus 1? Mason, what's -3 plus 1?
-3 plus 1.
Yep.
2.
-2. Come back to Earth, buddy.
What?
I said come back to Earth, buddy. Okay? You were kind of spacing off there. All right. So, -4 comma -2. But we like to have 5 points when we can. What does that mean? Okay? Bruh. Okay, cool. Now, we liked 4 a lot. Why did 4 work out well?
It was already in the fraction.
Okay? Because it reduced the fraction. 2 is even, though, and 2 didn't work super well. Try 3. Okay, let's try 3. See if that works.
Probably not.
Well, 0's even, and it works well.
Probably not. Yeah.
What's going to happen with the 3? Oh, we're going to get 9 over 4. We don't like that. Okay? We have to what? Okay, using the denominator, that's a good idea.
What about
What about what, Mason?
1? No, never mind.
Okay. What about 1/3?
What about 8?
Okay, 1/3 would kind of work well, but we'd end up with 1/4.
What about,
And then we have a fraction that we plugged in. So then we have a fraction as a point still.
what about 8?
What about 8?
Oh, never mind.
What about 40?
Let's try 8. 8 over 1. What's going to happen with the 4 and the 8? Cross reduce to what?
1
and 2.
1 and 2. So we're going to get y equals 3 times 2 is 6 over 1, so 6. What's 6 plus 1?
7.
Hey!
That
8 was
works.
good.
Good job, Mason.
Let's try negative 8.
No, what?
That's gonna be -7. Wait, no.
Oh, as if I wasn't going to say that anyway. What happens with 4 and negative 8? What happens with 4 and negative 8?
They add.
Cross reduce to 1 and...
2.
What kind of 2? Negative 2. Good catch. What's 3 times negative 2?
-6.
Negative 6 plus 1. So
Negative
it'd be
7.
negative 5.
Oh, -5. Sorry.
Now, why did 8 and negative 8 work well? Why did 8 and negative 8 work well? They go not because they go into 4, but because 4 goes into them. They're multiples of 4. So here's a hint, guys. I want you guys to write this down. I want you guys to write this hint down. Okay? So for the x here, when there's fractions, use multiples of the denominator. It's kind of a hint. Use multiples of the denominator. But 0 is like always going to work well, right?
Yeah.
0 is like our magic number.
Because it's even.
Because it's even, Tobin. Okay, now if I graph these points, negative 8 comma negative 5, negative 4 comma negative 2, 0 comma 1, 4 comma 4, and 8 comma 7.
Boom.
Does that make a straight line?
Yes, sir.
Yes.
And it should. Questions on that one? Okay, so what we found worked here well was picking multiples of 4. But would we always want to try plugging in 8 and negative 8 to our normal equations?
No.
Would I have wanted to plug in 8 or negative 8 into number 3? Why not?
It's not even. It doesn't go into it.
It goes into just fine, and we could get a good answer out of it. But what would happen with the number? It'd be either really big or really far negative, really small.
A number that I
Do we want that?
No.
Not if we can help it. If we have the choice, personally, I'm going to make my life easier. I don't know about y'all, but I'm going to make my life easier if I have the choice. Okay? So we picked multiples of the denominator when there was a fraction. Multiply with the variable. Now, what would you do? Where'd my number 5 go?
It disappeared.
No, it's not gone.
No.
I just have to re-find it. That's a bummer.
Why can't we see anything that you're doing on your iPad?
Well, that's unfortunate.
Because it's secret.
It's a secret.
No, that's it.
Ow.
I don't know. It's just the way the program displays it or doesn't display it. Kind of weird.
Oh.
There we go. I found it.
Dang it.
Okay. Y equals x over 3 plus 1. So is there a fraction with the variable? Kinda, but no. What's going to happen to the variable as soon as we plug it in? It's going to be divided by 3. So what kind of numbers might we want to pick here if it's going to divide by 3? Maddie? 3? Negative 3?
0.
0? What other numbers might we want to pick?
6.
6? 9? Would you rather pick 6 or 9? Why?
It's a lower.
Because it's smaller. You can plug in 9. It's a multiple.
Yeah.
Now, what kind of numbers are you picking here? You're picking what?
Even numbers.
Not necessarily. 3 and negative 3 are odd.
Low numbers.
What do these numbers have in common?
They're divisible by 3.
They're divisible by 3. They are multiples of 3. Go ahead and plug these 5 numbers in. When you have it or have a question. So after we plug these in, you get y equals negative 6 over 3 plus 1. Negative 6 divided by 3 is negative 2 plus 1, which is negative 1. Get negative 1, 0, 1, 2, and 3 if we continue on. Go ahead and graph this. Negative 6 comma negative 1. negative 3 comma 0, 0 comma 1, 3 comma 2, and 6 comma 3. Once again, using these multiples of 3 was really, really helpful for us. So be careful to keep a lookout to use multiples of that denominator.